Hi girls, Mr. Gilmore here. This is kind of more of a supplemental video than anything else. We've actually gone through all the material I wanted to run through in area, perimeter, and volume. This is our 8th lesson, 27th of March. So we've gone through all the material I wanted to go through in this chapter. The one thing that I wanted to do with this class is run through one or two of the tougher questions that you all now have submitted, and kind of just review over how these questions might have been done. So if you struggled with question 10, 11, or 12 in, I believe it was section 9.4, so that was the homework that was due yesterday and today, I'm going to ask that you look through this video because this video will help you kind of get a grasp of this material. So everything leading up to nets, I'm running through kind of the questions that were a bit tougher that some of you might have been struggling with, just so that you all kind of are on roughly the same level. And then I will give you homework at the very end. So if you do just want to see what the homework is, you can skip ahead in this video. But if you didn't get 10, 11, or 12 on pages, one second, I'm going to check which pages, 10, 11, or 12 on page 210 correct. So I'm going to ask that you look through this video and see how these questions were solved. Okay. So question 10 here, they give you a little box and they go, okay, the surface area is 150 centimeters squared, and they don't give you anything else. And they go, okay, what is the length of one edge of this cube? Okay, so if we know that this is a cube, then we know that all of these sides are the same length, aren't they? They're all some length x. We're going to use the algebra that we have learned coming up to this point to solve this problem, okay? So we know the height, the width, and the length are all some value x. So the first question is, tell us the length of one side of the cube. Okay, so surface area, as we already know, is 2 times height by width plus 2 times width by length plus 2 times height by length. Okay, so we know 150 here, which is the surface area, equals 2 times x plus 2 times x by x plus 2 times x by x. Okay, what do we call x multiplied by x? Well, we call it x squared. So we're going to change that up a little bit. So now it's 2x squared plus 2x squared plus 2x squared. So we know 150 equals 6x squared. Now we divide both sides of these equation by 6, as we already know. And we end up getting 25 equals x squared. If x squared equals 25, then we know that x equals, and in reality, we actually kind of know that x equals plus 5 or minus 5 centimeters. Obviously, it can't be negative 5 centimeters. That would make no sense for a box. So we're just going to say 5 centimeters. Okay, so we've got a cube. It's got a width, height, and length of 5 centimeters. And if you got question 1 all right, question 2 is what they call in maths trivial. As in, it's just really easy to do because they're just going, okay, what's the volume of this object? Well, it's going to be x by x by x, right? It's going to be the height by the width by the length. It's just going to be 5 by 5 by 5. So it'll end up just being 125 centimeters cubed. Okay, so that's question 10. So the key kind of tough part of this was just figuring out how to find one of the sides. Once you had one of the sides, it was literally just something you could do in your sleep. Now, question 11 here. Now, I've drawn this out for myself. It was a stack of blocks here, and then below it, another stack of blocks. And it had a few questions for you, okay? So it said, how many cubes are there in the stack? Well, you could figure this out by going, okay, so there's one stack here, one stack here. So 1, 2, 3, 4 stacks in the front. And then you could go and then on top of it, you go 1, 2, 3, 4, 5. So 5 stacks at the very top. And then it's reasonable to say in order for these 5 to be up here, there had to be 5 more below it, and then 1 extra here. So we had 5 at the top, plus 4 at the front, plus the 5 below that top row, plus this 1 extra here. Okay? So the total number of blocks was 14 blocks. Pretty straightforward. Next question here was find the volume of the stack. Now, almost all of you were able to reason that there's 14 blocks, but a lot of you went 14 by 3 because it says one of the sides is 3. Equals whatever. Is that correct? It's not. Because it's saying one of the sides is 3. But what's the volume of one block? Well, that's going to be one side multiplied by one side multiplied by another side. That's where a lot of you made the mistake. So you can realize, wait a second, that's 27 centimeters cubed. Okay. So now that we have the total volume of one block at 27 centimeters, we can now find the volume of all 14 blocks. And I'm not able to do that straight off the top of my head, so I'm going to take out my calculator. I'm going to go 27 multiplied by 14 should give you 378 centimeters cubed. So a lot of these questions start to ask you to kind of reason your way through what's happening in the math itself. Okay, so one final question here, question 12. And this has a soap box inside a bigger box. And it's saying how many, so it actually breaks this question down nicely for you. The first question it asks is how many soap blocks will fit along one 30-meter side. So we're looking at that 30-meter side. How many of these soap blocks will fit along? Well, each soap block is 5 centimeters wide, and it's 30 centimeters. So all we needed to do was just go 30 divided by 5, so 6. Okay, 6 blocks along. Great. The next one was how many packets, because they're not actually blocks, they're powder packets. How many packets will there be in the bottom layer when the box is full? Okay, so what we need to figure out is how many blocks across, how many blocks along, okay? So we need to do a similar question. How many blocks will fit all along this length here? And it's 24 divided by 6, so 4. And now what we need to go is okay, so I'm just going to write down blocks here. So if we can fit 6 blocks across and 4 blocks deep, then we can realize the number at the bottom row is going to be 6 blocks by 4 blocks. So 6 by 4, that'll end up giving us 24 blocks. So the idea here is that if we were to keep having more and more soap boxes, well, we'd end up with kind of a row, 4 rows all along the bottom of this. And each row would have 1, 2, 3, 4, 5, 6 soap blocks. Okay. Now, the final question, this third question here is, how many layers will there be when the box is full? Okay, so now we're doing a similar logic again. And we're going, okay, how many layers will there be? Sorry, how many boxes will there be when... So how many layers will there be when the box is full? So again, we need to go, okay, we've got 28 centimeters, and each block, each box we put on it is going to be 4 centimeters. So we'll end up with, okay, 7 layers. So we're going, okay, how many, if we stack each layer, how many stacks will we get? Well, we get 7 stacks or layers. And then finally, how many packets of soap will fit in the box altogether? So we have got 24 blocks per layer. We've got 7 layers. So we can go, okay, 24 multiplied by 7. I'm just going to plug that into a calculator as well for myself, because I'm not going to get that off the top of my head. It's going to be 168 blocks. So as you can see, each question breaks the overall question down. So if I wanted to give a tougher version of this question, I just start with how many blocks or how many boxes of soap can fit inside this box. And a similar enough question there appears with question 14. Okay, so if you had any trouble with question 14, look over question 12 and you'll realize, wait a second, 14 can be done in exactly the same way. The alternative method you could have done if you wanted to find out how many blocks would fit into the box is you could have just found the volume of one block, the volume of the total box, and then divided the total box volume by one of the blocks. The one problem there is it assumes you can perfectly fit boxes in. And let's say if this was 31 centimeters wide, obviously there would be a single centimeter left empty all along down the box. But 14 can be solved using the exact same method as I've used here. Okay, so we're going to do a little bit of revision work now. What I'm going to ask you girls to do, and this is going to be a good bit because I'm giving it to you over the weekend. You won't be getting any extra work over the weekend. So page 210, do question 13. Page 215, do question 9. This is very similar to 10 in the sense that question 9, page 215. That was me looking at the wrong one. That one's a bit unusual, as it's kind of not giving you all of the net of a cuboid, but that'll require a little bit of reasoning. And then page 216 to 218, we're going to do questions 1, 2, 4, 5, 7, 8, 11, and 12. I was thinking of giving you 14 and 15 as well. Actually, you know what? I do want you to do at least one more net question. I'm going to give you 14. 14's just really a different form of a net for the exact same shape. Great, girls. So please give an attempt at these questions, and I hope you all have a lovely weekend. As always, if you have questions, please feel free to contact me. All the best. Bye-bye.